This is section 3.2. And our first definition, an equation is a statement that indicates that two quantities are equal. And a solution to an equation is a value of the variable that makes the equation a true statement. So a solution is going to look something like x equals 3. And it's fine if you say 3 equals x. We could say 1x equals 3, but we don't usually put the coefficient 1 there. Avoid mistakes. It's important to distinguish between an equation and an expression. An equation has an equal sign, and we can solve equations. An expression does not have an equal sign. We cannot solve an expression. We can simplify an expression. So negative 2w equals 6. This is an equation, and we will learn how to solve this. X plus 8 has no equal sign. This is an expression. So what we're looking for in this problem is answering the question yes or no. Determine whether the given number is a solution to the equation. So we have the equation 2x minus 9 equals 3. And we are testing to see if our solution is x equals 6. Does that satisfy the equation? So remember that 2x minus 9 means 2 times x minus 9. So I'm going to plug 6 in for x and do 2 times 6 minus 9 to see if that equals 3. Well, 12 minus 9 actually equals 3. And this bottom identity we call a balance statement. And that 3 equals 3 gives us the indication that yes, the solution is x equals 6. And yes or no, determine whether this solution, p equals negative 2, does that satisfy the equation? So we have 20 equals 8p minus 4. Well, that's 20 equals 8 times p. So we're going to see if 8 times negative 2 minus 4 will satisfy this equation. So negative 16 minus 4 is negative 20. So 20 does not equal negative 20. So in fact, negative 2 was not the solution to this equation. The definition of a linear equation, let a, b, and c be numbers. A cannot be equal to 0. And a linear equation, and these are the equations we'll solve this semester, is an equation that we can write in the form ax plus b equals c. So we'll be solving equations such as 3x plus 2 equals 5, or 4y equals 16. In this case, b would be 0. Okay, so now we're going to look at the addition and subtraction properties of equality. So the addition property of equality says that if a equals b, then a plus c equals b plus c. So we can add any constant to both sides of the equation and still keep things balanced. So if you think of a classroom where the number of men is equal to the number of women. So if 3 more men come into the room, as long as 3 more women come into the room, it will still be balanced. Or if 2 men leave the room, as long as 2 women leave the room, it will still be balanced. So what we're saying is that we can always add or subtract the same constant to both sides of an equation to keep it balanced. So when we apply these properties, we're going to show that we're doing the exact same thing on both sides of the equation to keep it balanced. So my first equation is x minus 6 equals 18. So my goal is to get the x alone because my solution will look like x equals some number that satisfies this equation. So if we want to get this x alone, the number that we're trying to get rid of is this constant, -6. And we use addition or subtraction to eliminate a constant. So in this case, in order to eliminate -6, I'm going to write +6 underneath it. And whatever I do on the left side of the equal sign, I have to do on the right to keep things balanced. So I'm left with x here, and -6 plus 6, well, that just cancels out. That's equal to 0. And 18 plus 6 is 24. So my solution is x equals 24. And now I want to check my solution. So to check a solution, what we do is we begin with the original equation, x minus 6 equals 18. And we want to check that actually 24 minus 6 equals 18. So we plug our solution in for our variable and evaluate the expression. So 24 minus 6 is 18, and I'm left with this balance statement. So my solution is x equals 24. And we just did this check, 24 minus 6 equals 18. So my solution works. So the next equation I want to solve has the variable on the right side. So -12 equals x minus 7. So I'm looking for what value x will satisfy this equation. So what number minus 7 equals -12? So I want the x to be alone on the right side of the equation, and so I want to eliminate the -7. I'm going to write +7 and do the same thing on both sides of the equation. -12 plus 7 is -5. On the right side of the equation, my 7's have canceled. So my solution is -5 equals x, or you can say x equals -5, either way. And so now we're going to check this solution. So I'm going to start with the original equation, and I'm going to substitute -5 for x and make sure I'm plugging in -5 minus 7. And I want to make sure that I get a balance statement. In this case, -12 equals -12. Okay, so for this equation, I want to solve for y. So I want y alone on the left. So if y is alone, I need to get rid of this -4. So to eliminate a constant, you use addition or subtraction. -4 plus 4 will be 0, and I'm going to add 4 on both sides of the equation, and my solution, y equals 9. I'm going to check my solution by plugging plugging 9 in for y. So -4 plus 9 should equal 5. And it does, so that is my balance statement. Okay, solving z plus 11 equals 14. So again, my goal is to get the z alone on the left. To eliminate this constant, I will subtract 11 from both sides of the equation. And z equals 3. And I will check my solution by plugging 3 into the original equation. And 3 plus 11 equals 14. So my balance statement is 14 equals 14. Next, negative 8 equals 2 plus q. So to get the q alone, I need to get rid of the 2. So I subtract 2 on both sides of the equation. Negative 10 equals q is my solution. I will check my solution by plugging in negative 10 for q and making sure that I get a balanced statement. Okay, now what we're recognizing is on the left side of this equation, we have an expression with 3 terms. And so we're going to simplify this expression by combining like terms. So I have 3x minus 2x, and I can combine those, and 3 minus 2 is 1x, or just plain x. And on the right side of the equation, I also have an expression that can be simplified by combining like terms. And 12 minus 9 is 3. So after I've simplified each expression on the left and the right, then I'm ready to solve. And it will take one step to solve this equation. To get the x alone, I will add 8 to both sides of the equation, and x equals 11 is my solution. Now I want to check my solution in the original equation. I want to make sure to check the entire amount of work, so we have to start from the beginning. And we're going to plug 11 in for x. So I have negative 8 plus 3 times 11 minus 2 times 11, and that should equal 12 minus 9, which is 3. So negative 8 plus 33 minus 22 should equal 3. So this is 25 minus 22, and my balance statement 3 equals 3. Okay. Now for this one, the expression on the left needs to be simplified before I can start solving. So I am going to apply the distributive property, and I'm going to multiply twice. So negative 5 is good on the left. 2 times y is 2y. 2 times positive 1 is positive 2, minus y. So here I have some like terms, so I'm going to combine them. Before I solve the equation, I want to simplify this expression. So 2y minus a y is 1y plus 2. And at this point, I'm ready to solve my equation. It will take one step to solve the equation. To get y by itself, I'm going to subtract 2 from both sides of the equation, and negative 7 equals y is my solution. Now I want to check my solution, y equals negative 7, by plugging it into the original equation. So I have negative 5 equals 2 times negative 7 plus 1 minus negative 7. So I don't use the distributive property here because I can do what's within parentheses. So I'm just going to use order of operations. Negative 7 plus 1 is negative 6, and 2 times negative 6, and then minus negative 7, which is going to be the same as plus 7. So 2 times negative 6 is negative 12, plus 7 is negative 5. So there's my balance statement. So this is just showing the check. Okay, and now you have some equations